Welcome back to another lesson in MCV4U. Today we'll be talking about the chain rule. So if you recall from MHF4U, composite functions are functions that depend on another function. They are created when one function is substituted within another. So again, let me repeat that. Composite functions are functions that depend on another function. They are created when one function is substituted within another. So the notation here would be f of g of x, or f of g of x here in these two notations, again, which is said to be f of g of x. In this case, again, g of x is often referred to as the inner function, while f of x is referred to as the outer function. Let's take a look at this example. So for each of the following composite functions, let's identify the inner function and then identify the outer function. So here, if we look at the inner function, we look at the inner and outer function of y is equal to 3x minus 7. So the outer function is x to the power of 5, and the inner function is 3x minus 7. If you look at b here, the outer function would be x to the power of 3, and the inner function is 5x plus 1 over 2x minus 4. And finally, this last one here, for sine 3x squared plus 1, the outer function would be sine x, and the inner function is 3x squared plus 1. And this will be important as we look at the chain rule because we'll have to find the derivatives of the outside function and the derivative of the inside function. So let's take a look at, again, to find the derivative of these composite functions. So the chain rule, so if h of x is equal to f of g of x, then h prime of x is equal to f prime times g of f prime of g of x times g prime of x. So it would be the derivative of the outside multiplied by the derivative of the inside. So example, the derivative of the other function multiplied by the derivative of the inner function. So or again, if y is equal to f of u and u is equal to g of x, then dy over dx is equal to dy over du times du over dx. So let's look at this power function as an example. So here it says differentiate h of x is equal to p of x cubed. So here, if we look at the outer function, here we have something cubed. In our inner function, we have as p of x. Okay, so if we use what we just looked at in terms of h prime of x is equal to the derivative of the outside. So the derivative of the outside would be 3 bracket c of x squared times c prime of x. Another way to look at this as well is if we look at h of x, if we have p of x to the power of 3, we can rewrite it as p to the x times p of x times p of x. And here, again, if we use the product rule, we have h prime of x is equal to p prime of x times p of x times p of x plus p of x times p prime of x times p of x plus p of x times p of x times p prime of x. If we simplify that, we will have p prime of x times p of x squared plus the same thing for each of these other ones. So p prime of x times p of x squared. And the same one for this last group here as well. P prime of x times p of x squared. And then if we further simplify this, we will get 3 p prime of x times p of x squared. Okay, if we look at this now, again, so if we look at this example, given that h of x is equal to f of g of x, f of x is equal to x squared, and g of x is equal to 3x plus 7, we have to find now h of x and find h prime of x. So h of x here is equal to 3x plus 7 squared. So what we're doing here again is we are subbing g of x into this f of x function of x squared. And so we'll put 3x plus 7 into x, which gives us 3x plus 7 squared. And h prime of x, again, we're going to do the derivative of the outside, which is 2 bracket 3x plus 7. So we're going to bring the 2 down, right? Keep whatever's in the inside of 3x plus 7. And we're going to multiply that by the derivative of the inside of 3x plus 7, which is 3. So here we can simplify. It'll be 6, 3x plus 7 will be h prime of x. So let's look at example 2 here. So let's find the derivative in simplified factored form. So f of x is equal to 2x squared plus 4x plus 3 to the power of 5. So again here, f prime of x, again derivatively outside, 5, 2x to the power of 2 plus 4x plus 3 to the power of n minus 1, which would be 4 here, times the derivative of the inside, which would be 4x plus 4. So here, if we can factor out a common factor from 4x plus 4 with 4, so 5 here, 2x squared plus 4x plus 3 to the power of 4 times 4 times x plus 1. So 5 times 4 will give us 20. So here we have 20 x plus 1, 2x squared plus 4x plus 3 to the power of 4. Okay, so this next question here shows us f of x is equal to square root x squared minus 3x plus 4. Remember, if you recall, when we looked at values under the square root before and the derivative, recall y is equal to square root x is equal to 1 over, so this derivative of that is equal to 1 over 2 square root x. Okay. So here, let's just rewrite this as f prime of x is equal to x squared minus 3x plus 4 to the power of 1 over 2. So that's just f of x. And we'll do the derivative of the outside first. So bring down the 1/2. So f prime of x is equal to 1 over 2, and that's square root x squared minus 3x plus 4, and multiplied by 2x. So the square root of the inside, which is 2x minus 3. So f prime of x is equal to 2x minus 3 over 2 square root x squared minus 3x plus 4. Okay, so now we're going to combine the idea of product rule and chain rule. So if we label x squared minus 9 to the power of 4 as a, and 2x minus 1 to the power of 3 as b, we know that with the product rule, y prime is equal to a prime times b plus a times b prime. So a prime times b plus a times b prime. So here, if we look, y prime is equal, so the first thing we'll do is we'll find a prime. So here we're using the product rule to find the derivative of a. So do the outside first, so 4 bracket x squared minus 9 to the power of 3. And then we'll do the derivative of the inside, which is 2x. So this would be, here is a prime multiplied by b, which is 2x, which is 2x minus 1 to the power of 3. So this would be b here, plus a, which we can write as simply x squared minus 9 to the power of 4. So that's a times b prime. So again, we're using the chain rule here. So here we do the outside, which is 3 bracket 2x minus 1 to the power of 2. And that would be derivative of b, or b prime. And then times by the inside, which is 2. And so that entire thing would be b prime here. Okay, so here now, after we have gotten a prime, b, a, and b prime from using the product rule, now we can see if there is any common factors we could factor out. So here we see that in the first group of a prime b, we have a squared minus 9 power 3. We have 2, and we have 2x minus 1. In the second one, we have similar things we can draw out there. So we have x squared minus 9, this to the power of 4, but still x squared minus 9. And we have 2x minus 1, power of 2, and we have that value of 2. So here we can factor out 2x squared minus 9 to the power of 3 times 2x minus 1 to the power of 2. And what's left over is we have 4x, 2x minus 1, plus 3x squared minus 9. And now we can expand and then simplify as much as possible. So here we have 2x squared minus 9 cubed, 2x minus 1 squared. Here we we distribute this, we get 8x squared minus 4x plus 3x squared minus 27. So here we have 2x squared minus 9 to the power of 3, 2x minus 1 squared, and here we add like terms. We have 11x squared minus 4x minus 27. Here we can rewrite x squared minus 9 and then factor into x minus 3, x plus 3 to give us our final answer of 2x minus 3 cubed, x plus 3 cubed, 2x minus 1 squared, and our expression of 11x squared minus 4x minus 27. So again, in this particular question, we combine both the product rule and the chain rule together to be able to solve for this particular derivative. Okay, so let's look at this last question. So again, when we're looking at derivatives, again, the idea when we looked at these derivatives is to help us find these slopes of the tangent, and then we can now find the equation of tangent based on these principles that we've learned. So here it says find the equation of the tangent to the curve y is equal to x squared minus 2 to the power of 3 at x is equal to 1. So first thing we want to do is you want to find the point for the y value that's associated with x is equal to 1 on this particular curve. So the y value at x is equal to 1 here is equal to 1 squared minus 2 to the power 3, which is equal to just negative 1. And so our point that we'll use to sub in at the end will be 1 and negative 1. So again, if you recall, again, the derivative of a function provides us with the slope of the tangent. So here we have, again, we have our equation y is equal to mx plus b as the line. Again, m is equal to y prime. And so let's find the derivative. So here we have y is equal to x squared minus 2 to the power of 3. So y prime is equal to the outside, so 3 bracket x squared minus 2 to the power of 2 times the inside, which is 2x. So here, again, our m value, y prime at x is equal to 1 is equal, so we can sub that in, so 3 bracket 1 minus 2 squared times 2 times 1. That will give us 3 times 2, which is equal 6. So we now know that our slope is equal to 6, so y is equal to 6x plus b, and we'll sub in point 1, -1, which we found at the beginning. So now we have -1 is equal to 6 times 1 plus b, -1 equals 6 plus b, -1 minus 6 is equal to b, and therefore b is equal to -7. And so our final equation is therefore y is equal to 6x minus 7. Okay, I just would like to look at an additional example as well. And in this example, it says find the slope of the normal to the curve y is equal to 1 over x squared minus 2 to the power 3 at x is equal to 1. So a little bit of vocabulary here. The normal is a line through the point of the tangent that is perpendicular that is perpendicular to the tangent. And remember, if you recall, perpendicular, the slope, again, because it's 90 degrees, the slope is the negative reciprocal. And the slope is the negative reciprocal of the value of the regular slope that you get. So if you look at this here, you have y is equal to 1 over x squared minus 2 to the power 3 at x is equal to 1. First thing you want to do here is you want to rewrite the equation as x squared minus 2 to the power of -3. First thing we'll do is we'll bring down the -3. So on the outside, x squared minus 2 to the power of -4, and then factor out the inside, which is 2x. So here we get y is equal to -3 times 2x over x squared minus 2 to the power of 4. This is the derivative here, and we're going to sub in. So we're going to find here the slope. And the slope here is y prime at x is equal to 1. So we'll sub that in. So that would be equal to -3 times 2 times 1 divided by 1 squared minus 2 to the power of 4. So here we have -3 times 2, which is -6 over 1 minus 2 squared, or 1 minus 2 to the power of 4 will give us 1. So here it's -6 over 1. Remember, here we're trying to find the normal, or the line that's perpendicular, so we need to find the negative reciprocal of this. So the slope of the normal, or the perpendicular line here, will be equal to 1 over 6, since it's the negative reciprocal. And here, if we were going to try to find, again, the equation of the normal, then we'd have to sub in x is equal to 1 back into this formula to find the y value that corresponds at x is equal to 1, and then we would sub that point into our equation y is equal to mx plus b. So just an additional example here, looking at a little bit of a different idea.